Question 21. Prove algebraically that the difference between the squares of any two consecutive integers is equal to the sum of these two integers. It's got a little star next to it, so it's all about the proof and our reasoning behind our answers. Now, an integer is a whole number, so we're going to have to just use a letter to represent any integer, any whole number. So I'm just going to keep it nice and easy, and we'll use x. So the difference between the squares of any two consecutive integers. Consecutive means next to each other. So in this situation, we could have our first number, any whole number, could be x. The one after it would be x plus 1. So they're the two numbers that we're going to use. So that could be 100 and 101 for all we care. So the difference between the squares of these. So we have x squared. Actually, probably want to get the bigger one first. So we have x plus 1 squared. Take away x squared, because that's going to be the second number squared, take away the first number squared, is equal to the sum of the two integers. So if we added those two together, that would be x plus 1. So that's basically what the question has just asked us. Difference between two square consecutive numbers. So that's x plus 1 and x squared. So we find the difference between those two should equal the same as this. So let's resolve the left-hand side first. We have x plus 1 squared. So that's going to be x plus 1 multiplied by x plus 1. So x plus 1 times x plus 1. There are a lot of different methods for this one. I'm just going to make sure we use FOIL, first, outer, inner, last. So x times x is x squared. X times 1 is x. 1 times x is x. 1 times 1 is 1. So if we simplify that, we have x squared plus 2x plus 1. So the difference between these two values, I shall draw a little arrow to show this is where the next calculation is. We're going to have x squared plus 2x plus 1, take away our x squared, is equal to, well, that's x plus 1, so that's 2x plus 1. If we simplify this, we have the x squared and the negative x squared cancel each other out. So we have 2x plus 1 is equal to 2x plus 1. So therefore we've just proven that this statement is true.